All right. Hello, students. Hopefully you can hear me out there. I'll wait for a few people to come on in. I just got the stream started here. Had a few technical difficulties. All right. So welcome. My name is Mr. Rich. I am a math tutor and coach here in Jacksonville, Florida, and I help students with their ACT and SAT prep, as well as teach all levels of high school math. I teach AP Calc and AP Stats here in Jacksonville. And today I wanted to just do a review for the SAT by working through some problems and giving you some last minute tips before your test on Saturday. The reason I was delayed in getting in here was I started the wrong stream. I have a stream set up for next Thursday for the ACT, which happens to be a week from this Saturday, and so I was actually in the wrong stream. So anyways, so we'll get started here in just a second. So the plan for tonight will be, I've got some problems that I'm going to be working from the March I believe it was the March 22 QAS. That was a released test. And I've got more than enough to cover for a full hour. And I'll give you some tips as well as pacing. If you're one of my students that I've helped get ready for the SAT, you know that I'm an advocate for a two-pass system as you're moving through your test. And I'll kind of explain that to you towards the end of our session today. But if you're one of my students, you'll probably have heard that spiel already. But at any rate, okay, so I'm going to share my screen here in just a second. So let me get that set up. And if you have any questions as we're going through here, you can put them into the comments. If you're watching me on YouTube, you should be able to post comments that I'll see here in my streaming service, and then I can answer those. So feel free to do that if you have any questions at all about the problem or anything else as we are working together here for the next hour. Okay, let's do this. See if I can get it set up here. All right, almost got it. So stand by and we shall start. So you should see my screen now, and we're going to work through some problems here. And here is the very first one. And if you are with me, go ahead and post a comment. Let me know that you're here. Just say hi or give me a thumbs up or something like that. So here's the first question that I want to go over. It is a systems of equation problem, and they're pretty frequent on the SAT. We've worked through some practice tests recently and had as many as 3, I think, or actually I think we had 4 systems of equation types problems in one section, and I think it was in section 3. And so they're pretty common. And so it says here, how many solutions does the given system of equations have, right? They don't want us to solve it. They just want to know how many solutions are there. Well, we could go ahead and solve it and then find out how many solutions there are. But if you look at these functions, students, you'll see that these are both linear functions. Okay, both of these, there's no exponents on my variables here. They are linear equations. So that means there's either 0 solutions if the 2 lines are parallel and don't intersect, or there's exactly 1 if they are not parallel, there's no way that there would be exactly 2, right? There's no way for 2 lines to intersect at just 2 spots on the graph. Or there's infinitely many solutions. And that would be possible if the 2 equations actually were representing the same line. So what I'm going to do here is I'm going to go ahead and I'm going to distribute the 2 through the parentheses and see what we have, right? So this would be 4x plus 2y is equal to 20. And hey, Nick, glad you could join. All right. And then this one, not doing anything to that, but I will put that up here. And if I were to solve this, I could probably use elimination most easily here. And I would multiply, I think maybe I'll multiply the bottom equation here by a -3. So I could produce a negative 6y right there. And if I did that, my system of equations, that second equation there would become negative 12x minus 6y equals a negative 60. And this one up here would be 2x plus 6y equals 2. And then when I add those together, I'm going to get negative 10x. Those cancel to 0. And then this looks to be like a negative 58 right there. And so there's one solution to this, right? X is going to be a positive 5.8. Now, and so my answer here is going to be that there's exactly one solution. Now, I want to tell you something else here. Another way to approach a problem like this when they're not asking me to solve the system, but how many solutions there are. You can always put these equations into slope-intercept form and then compare their slopes and intercepts to see if they are parallel or the same line, or if they are not parallel and that they intersect. So you could do that. That wouldn't be too hard at all. So you could take this first equation and isolate the 6y by moving the 2x over and calling that negative 2x plus 2. And you divide by 6, and you're going to get a negative 1/3 x, and then this would be a 1/3. I could, after I have, well, here I could then just divide both sides by 2, and that one coming down here, if I divide both sides of that equation by 2, I get 2x plus y is equal to 10. And then I move that 2x over. And those are the 2 equations. And obviously, they're going to intersect at one point because I know that they have one has a slope of -2 and one has a slope of negative 1/3. That's all there is to it. All right, let's move on from there. Like I said, if you have any questions, feel free to chime in on the chat, and I will, especially if you see me make a mistake. I've been known to make a mistake here and there. But if you see something that doesn't look right, let me know. All right, I picked a problem here that's an absolute value problem because absolute value functions they're just hard to deal with for a number of reasons, mainly because absolute value functions are really piecewise functions. If you remember from Algebra 2, and if you've taken pre-calculus, you've worked with piecewise functions, and they present their own set of challenges. And that's basically what an absolute value function is. It's piecewise. But let's take a look at the algebra approach to find this. This says, though, what is the sum of the solutions to the given equation? Well, I'm just going to go ahead and find the 2 solutions and then add them together. Okay, so let's do that. And here's the algebra approach when you're working with an absolute value equation. You are going to isolate the absolute value portion. Okay, so I would subtract 4 from both sides. And so you have the absolute value of 2x plus 6 is equal to 4. And then what you're going to do is you're going to split this up into 2 separate equations, because if it's an absolute value, that means that the inside part could just remain as it is. 2x plus 6 is equal to 4. Or the inside part could be the negative of 2x plus 6, meaning it would look like this. and then you could solve both of those equations independently and then get your two solutions. Here, I'm going to subtract 6 on both sides and get this, and then divide by 2, and I get -1 as one of my solutions. Here, I'm going to move that negative over to the other side by dividing by -1, and so I get that. I'm going to subtract 6 on both sides and get 2x equals -10, which would then give me x equals -5. And it looks like the sum of those two solutions is -6. Hey. Okay. All right. So let's keep going. Let's go to the next problem here. All right. So the next one that I picked is a quadratic, a parabola, where they're basically wanting you to match the graph to the proper equation. And let's read this and highlight what's the most important parts here. So this says that the graph shown models the height y in feet of a volleyball x seconds after it was hit by a player. Which equation represents the relationship between the height of the volleyball and the time since it was hit? Okay, yeah, that makes sense. Time and height. They just want me to find the equation. Well, what they're really testing you here, class, is to see if you understand one of the forms of a quadratic equation, right? And I'm gonna take this opportunity here just to cover quadratics for a second. As you go into this test, you want to know that there's 3 ways that you could express a quadratic equation, and they all have their purposes and their pluses and minuses. But I'm going to first give you the standard form, ax squared plus bx plus c. That is the standard form. Another way that you could write a quadratic is in what we call the vertex form, where it's x minus h squared plus k. That's what we call vertex form for a quadratic. And that's really handy because it tells you immediately when you look at the equation what's the vertex, right? The vertex is going to be h comma k. The other form, the third way that you could write a quadratic is in what we would call factored form. If it's a factorable quadratic equation, you could write it like this: x minus x1, x minus x2, where x1 and x2 are the roots of the equation. Now, when I look at my answers here, I see that 3 of my 4 equations really are written in vertex form. And that kind of makes sense because when I look at this, I see the vertex. I can tell the coordinates of the vertex. It's 0.25, comma 6. Those are the coordinates. And that looks like this right here, right? They put 0.25 in right here for h, and then they put 6 in for k. Now, there's a -16, but all of the answers have an a of -16. And by the way, when you look at these 3 forms of a quadratic, the one thing that they all have in common is the a. The a in one is the same as the a in the other 2. The other parts of them, the b's and the c's right here, and the h and the k and the x1, x2, those are all different and mean different things. But they do have a coefficient in front that's the same. And all of the answers have a -16, so I'm not really worried about that. So my answer is D. Now, if you wanted to make sure that was right, what you could do is make sure that 0, comma 5 is a solution to that equation. So if you were to put 5 in for y and then 0 in for x, you would see that that is true, right? This is 1/4. When you square 1/4, you get 1/16. So that would be a -16 times 1/16, which would be a -1. -1 plus 6 is 5. Okay. That is what we have there. All right, so it looks like we got about 4 people here. If you're watching this on the replay, and you're just joining us, my name is Mr. Rich, and I am a high school math teacher and math coach in Jacksonville, Florida. We are covering the SAT, an SAT review for the test this coming Saturday. If you've got any comments or questions, be sure to post them over in the chat. All right, that's quadratics. Let's go to the next one. The function f is defined by f of x equals this function right here. What is the y-intercept of the graph in the xy plane? Right? Y-intercepts for any function, it doesn't matter what the function is or what kind of function it is. If you're looking for a y-intercept, you plug 0 in for x, because every point that's on the y-axis that would be a y-intercept has an x-coordinate of 0. So that means if you're trying to find a y-intercept, you are you are definitely going to be finding f of 0. So in this case, you're doing -8 times 6 to the 0 and then -4. And they're checking here to make sure that you know how to do proper order of operations, what we call Pemdas. Or somebody told me recently, GEMDAS is another one. Instead of parentheses, they use G for grouping. Okay, whatever. But you have to do the multiplication here first. Well, actually, you're evaluating the exponent first, right? 6 to the 0 is a 1. Right? It's not 0. Notice they have an answer here waiting for you to make a mistake and call that 0. No, 6 to the 0 is 1. Anything raised to the 0 power is the number 1, except for 0 to the 0, that would be undefined. But 6 to the 0 is 1. So this would be -8 times 1, or -8 minus 4. So that is -12. F of 0 is -12. There's my y-intercept. All right. Very good. Well, let's move on. All right. I like this one. This one was kind of a unique problem that I have not seen anything really like it on SAT tests for a while. And they have this set up for you to make a mistake. I would imagine a common mistake here. They want me to find out what's equivalent to this, where Q is greater than 0, R is less than 0. I'm not too worried about that. I'm just going to do what I think I need to do here to solve this. And here's what I'm going to do. I look at all of my answers other than this one. Everything here is radicals, and I don't see any fractional exponents. So I think what I'm going to do here is I'm going to convert these into fractional exponents. This would be, I don't think I'm going to do that. I am going to go straight to an idea about these fractional exponents, 2/3. I'm going to do this, class. What I'm going to do is I'm going to take the square root of 2q plus the square root of r, and I'm going to raise it to the second power, and then I'm going to raise that to the 1/3 power. Now, why would I do that? I will tell you why I would do that. Number one reason why I would do that is I do see that I have a third root in 3 of my answers, and that would be a third root. And therefore, I could just deal with this and square that. The other reason that I would do that, I think there was a second reason why I wanted to do that. Well, let me explain how I know I can do that, okay? Because that when I raise powers to powers, I multiply. So raising to the 2/3 is the same as raising to the second and then raising again to the 1/3. And if I wanted, if it suited my purposes, I could switch that around. I could raise that to the 1/3 and that to the second power. but that's not going to really be suiting my purposes here. So I'm going to square that and then raise that to the 1/3 power. Right. Now, the other thing that I want to tell you about, class, and I always make sure that my students know how to square a binomial, right? And I'm going to show you an example of squaring a binomial, and then I'll apply it to this. What I mean by squaring a binomial is that if you have, we'll say, x plus 5 raised to the 2nd power, and you want to square that, right? You would normally, if you were in maybe Algebra 1, you might write it out as x plus 5 and do something that your teacher said called FOIL, which basically is just distributing the x and the 5 through the other x and 5. But there's a faster way to do it, and it's something that you really do need to know how to do, just for speed and also for application to a problem like this. If you're going to square a binomial, you basically do square the first term, and you do square the last term. 5 squared is 25. The middle term that you would get is the product of the two terms times 2. 5 times x is 5x times 2 is 10x. And you say, well, that doesn't save too much time. Well, I'm not going to go into why you need to be able to do this. It also helps when you are trying to factor perfect square binomials. It helps to recognize that, this would factor into that. Now, so what I'm going to do is I'm going to apply that to this. So if I'm squaring this binomial, I'm going to square the first term, which is 2q, right? Squaring a square root removes the square root. Then this one is going to be twice the product of those two terms. Well, the product of root 2q and root r would be root 2qr. But I have to double that, right? Just like I doubled 5 times x is 5x times 2 gives me 10x. I have to multiply the product by 2. And then I square the last term, and the square of square root of r is just r. And this is raised to the 1/3 power. All right, now it comes time to match this thing up, and I'm looking at my answers, and I don't like what I see here. 2qr times 2. I definitely don't like what I see. Let's see. So we multiplied and then doubled root 2qr. I'm looking. I'm pretty sure, right, that we're not going with A here, and I don't like this one either, and it comes down to these two, but I don't have a 2r, and I have a 2 underneath here. I'm not sure, class. Let's come back to it. Let's keep going. All right, let's move down to this one. Okay, this is a pretty simple problem, but it is going to allow me to talk about how to deal with fractions and equations. Most of you probably know how to do this, but right, we just don't like fractions in our equations. They make things a little harder, but I can remove fractions by multiplying both sides of my equation by the least common denominator of any fractions that are present. That's easy because I have a denominator of 3 in both of these. So I'm going to multiply both sides by 3 right off the bat. I'm going to do this, and I'm going to do that. I have to use the distributive property. 3 times 2x over 3 is just 2x. 3 times -2, -6. I'm going to distribute here. That gives me x plus 3. And don't forget, we have to answer 2x here. This is an open response question. And so then I will subtract x on both sides. I will add 6 on both sides. X is 9, so 2x is going to be 18. And that would be my bubbled in answer right there. All right, let's keep moving on here to a geometry question. Points A and B lie on a circle with radius 4 meters, and arc AB has length in meters. The length 4 pi over 5 of arc AB is what fraction of the circumference of the circle? So there's some circle. It would have been nice if they gave us a picture, but we'll draw a picture. And we have a circle that has a radius of 4. And there's an arc AB. And I'll just call that point A, and I'll call that B. And so therefore, they're talking about this arc AB. And arc AB has a length, a linear distance of 4 pi over 5. And they want to know what fraction that is of the whole circumference. Okay, that's easy enough. I just need to know what is the circumference of the circle. And that requires you to know a formula. So going into the test, this is a formula that you hopefully have memorized, right? The circumference, or the distance around the circle, is 2 pi r. We know the radius is 4, so that means that my circumference is going to be 8 pi. So what I'm going to do, if I know that this arc is 4 pi over 5, I'm going to set it up as 4 pi over 5 over 8 pi, right? That would give me the fraction, the length as a fraction of the circumference of the circle. Now, what am I going to do here? Well, I'm going to do a keep, change, flip, right? I'm doing division with fractions here. So I'm going to take my 4 pi over 5, change the division to multiplication, and then flip the 8 pi, and it'd be 1 over 8 pi. The pi's would cancel. You get 4 over 40, which is 1 over 10. So it's 1/10 basically. So you would want to bubble in 1/10 on your bubble answer sheet. Don't forget, class, if you've been taking this test for any number of times, you already know this, but you can't have negative answers on your free response questions. Right? There's no way for you to bubble in a negative. That's why if there is a negative involved, somehow they have you do some manipulation to the answer to make it a positive. Like they'll maybe ask you to take the absolute value or something like that. But if your answer is negative, then you need to take another look at what you did or what the problem is asking for. Next, the function g is defined by g of x equals 4x squared minus 3. For what positive value of x is g of x equal to 13? So there must be two values, but they want the positive one. And one of the things I tell my students, right, is that when you're doing problems, you always have to have in the back of your mind the idea that you're going to be doing a lot of substitution. You're taking things from one equation and sticking them into another equation and making something new. It's just something that we do a lot in algebra when we're solving problems. And here we're going to do that, right? This says g of x is equal to 13. Well, guess what? I'm going to do a substitution, right? I'm going to put 13 in for g of x. And this equation becomes 13 equals 4x squared minus 3. And then I set off to solve that. I'm going to add 3 to both sides, and I get 16 equals 4x squared. And then x squared is equal to 4. And then I square root both sides to get my answer. And I get 2. X is going to be equal to the square root of 4. There's two answers, right? Positive or negative 2. Whenever I square root a number, I have to consider that there's two possible answers. But there's my answer. For what positive value, right? And I'm always making sure, right, that I am answering the right thing. They could have asked me for what value of x squared. They probably wouldn't have said positive, but right, you are always making sure when you go grab that answer, okay, am I answering what they really want? All right, yeah, they want x. And so we got it. Moving on. This is a problem too that I saw on this QAS release that I just haven't seen very much on previous SATs. Maybe I haven't been looking at the right ones, but where they give you a scatter plot and then they want you to come up with the equation of the best fit line. One of the things that you need to know about the SAT when it comes to scatter plots, right? These scatter plots are where you're plotting actual data points that you've collected, ordered pairs that came from two variables that have some association with one another. And then you plot the data. And then if you see that there is a linear relationship between them by just kind of visualizing what the function might look like, if it's a straight line, then you can draw, or actually, if you take statistics, you'll learn that it's called least squares regression. But we come up with a line that passes through the center of the points. And then we come up with an equation for that line so that we could then make predictions of the y value based on the x value as an input. But here they just want you to, what they're wanting you to do is kind of draw what the best fit line would be and then say what equation would be like the best equation. Well, first of all, it's got a negative slope. So any answers that have a positive slope are not going to be an answer. That means B is out because that has a slope of positive 1. So there's no way. And same with D. Positive 1x, that's a positive slope. And then this definitely is going to be A, because if I were to just flip-flop that, it's negative x plus 6. So slope of negative 1 and a y-intercept of 6. And there you go. Y-intercept of about 6. Moving on. if 6 over x plus 1 is equal to 3, what's the value of x plus 1? Well, there's a couple of things that you could do here when you look at this problem. One thing I could do, I'm gonna say maybe the fastest thing would be to flip both sides of the equation. And you may say, how can you do that? Well, I could raise both sides to the -1 power. That's something that we can do in algebra, to both sides of an equation. And raising to the -1 power means to invert or flip the fraction. So my equation then would become x plus 1 over 6 is equal to 1 over 3, right? Because this can be written as 3 over 1. So it would be 1 over 3. And then I get the thing that I need, which is x plus 1, by just multiplying both sides by 6. And when I multiply both sides by 6, I get x plus 1 is equal to 1/3 times 6. So x plus 1 is equal to 2. Okay, now one of the things that they are setting you up here is to make a mistake and maybe not pay attention to what they're asking for and solve for x and get x equals 1. And you're thinking, man, I got it. Solution. Like, yeah, but you didn't answer the right thing, which is x plus 1. I also want to take this opportunity to explain also kind of an overall strategy when it comes to solving equations that involve what we call rational functions, that is fractions with variables in the fractions. And that is that if you can write your equation as a fraction, one fraction on each side of the equation, you can transform the equation by doing what we call cross multiplication. Because if two fractions are equal to each other, then that means that their cross multiples have to be the same. So that means one other way that you could do this is just right off the bat, just say, oh, well, I've got two fractions. So that multiple, which is 3 times x plus 1, has to be the same as the other cross multiple. 6 times 1 is 6. And then divide both sides by 3. And then you get x plus 1 is equal to 2. Okay, either way, it wasn't really important on this one. But there are quite a few problems that are rational equations that you do want to cross multiply. All right. I have no idea where we're at in terms of the numbers of these problems, or if we're getting close to the end. But let's keep on rolling here. Another scatter plot problem. This says that the scatter plot shows the relationship between two variables, x and y. A line of best fit is shown. So in this problem, they went ahead and gave you the line that passes through the middle of the points. And it says, for how many of the data points is the actual y value at least 1 greater than the y value predicted by the line of best fit? Now, if you haven't taken a statistics course, AP Stats, or in our county, I believe it's probability and statistics is the non-AP version. If you haven't taken that class, you're a bit of a disadvantage here. But if you have taken those, you kind of know what they're asking, right? This line of best fit is what we call a prediction line, right? Once you've created the line after you've made your scatter plot, I'm talking about what we do in statistics. Once you've made your line of best fit, you then use the line to make predictions. So I could say, well, what if x is 7? What's the predicted y value? Well, I would say, well, when x is 7, I come up, I hit the line. Oh, the predicted value is 8. Or x is 4. The predicted value is 3. Now, they're just saying, for how many is the actual y value? Well, the actual y value that they're talking about are the y values of the points, because those are actual real data points that they plotted from some measurable data that they collected, and they plotted them. And so what I'm looking for here is how many of these data points, when I look at their distance from the vertical distance down to the line of best fit, how many of them are at least 1 unit of measure away vertically from the line. So this actual y value is right on the line. So it is not at least 1 unit greater. I mean, is the y value at least 1 greater than the y value? That's not either. This actual y value is about 2 units less than the predicted. See, the predicted value here is 3, but the actual y value at x equals 4 was 1. But it wasn't at least 1 greater than the predicted. So that doesn't count either. This one does count because it's 1 unit higher than, greater than the y value predicted by the regression line. So that would count. That point right here is at least 1. So my answer here is 2. All right. Any questions on that? No questions. Okay, let's keep moving on. This is a probability question. This is what we call a two-way table. I've got 2 what we call categorical variables. I've got the variable we looked at. Well, let's read it first and then we'll talk about it here. It says the table shows the results of a poll that was used to determine support for a county proposal. The results are categorized by county and opinion. If one person who responded to the poll is selected at random, which of the following statements results in the greatest value? All right, so I need to find which of these is the greatest value. Now, as I said, it's a two-way table because they're plotting two variables. What are people's opinions on the proposal? And what county do they live in? And I'm going to have to go, I got to go and look at what the answers are to these one by one and see which one's greater. These are time-consuming problems, or maybe there's a trend that I'll see that might speed it up for me. But let's just tackle answer A. It says the probability that the person, talking about the one person that we select at random, is undecided given that the person is from county 1. This is what we call a conditional probability in statistics, because we are not talking about all 2,745 people in the poll. We're not talking about all of them in this problem, because they're saying, given that we know the person's from county 1, that means I'm just dealing with people in county 1. I already know that if they're from county 1. So what's the probability that they are undecided? It would be 95 over 1601. And I'm not going to get that as a decimal. I have a feeling we'll be able to figure this out. It'll be an obvious answer, but let's see. B, the probability that the person is undecided given that they're from county 2. All right. Looking right here. Undecided, 91 over 1144. These numbers are very close, but this number is much less in county 2. So this one's going to be higher, right? B is higher than A. If you, this would be, I believe this is the calculator active port. So you could use your calculator to get it as a decimal. Answer C says the probability that the person is from county 1, given that the person is undecided. Well, now the condition is that the person we selected is undecided. So now I am just talking about the undecideds. What's the probability that the person's from county 1, given that they're undecided? That's 95 out of 186. That's way higher than either of those two. And then D, the probability the person is from county 2, given that the person is undecided. Given that the person, so what I want you to remember, if they do ask you a given that the something, that's a restriction. You are restricting the people in your two-way table, or the subjects, whatever they are in the table. That's your restriction. That's my restriction, undecided, county 2. So this would be 91 out of 186. All right, which one is higher? Definitely these are lower. And since these two denominators here are the same, that has to be the higher value. So my answer here would be C. All right. Okay. Let's keep going on here. It's about 9:19. I was going to go for about an hour, and I hope this is useful to you as we work through these problems. Let's look. I like this one because this one is one of those problems that they put in there that could take you a long time or a short time, depending on how you approach it. They say, how many distinct real solutions does the given equation have? And it's a weird equation. You might be tempted to say, well, I'm going to go ahead and square that, distribute that, and then solve it for x. But I'm going to show you something else that you would want to do. What you can do, and a lot of teachers don't teach this this way, but some do. And if you go to calculus, you'll see that we use this kind of substitution quite a bit. But what I'm going to do is I'm going to, since I have an x minus 5 right here and it's squared, and then I have another x minus 5 that's not squared, I'm going to let I'm going to use a dummy variable that we call u. I'm going to let that be x minus 5. And then I'm going to substitute that in. That would make that equation u squared plus 10u plus 25. It's a quadratic equation, or a quadratic type. It's a quadratic equation, but it's much simpler to solve this because this is u plus 5 times u plus 5 squared, like that. Now, how many solutions are there to that? There's one solution. There's one solution. U is equal to -5. Now, my answer here is exactly one solution. And now, what is the solution? Well, it's not -5, but if I wanted to find out what the solution was, I would then replace this U with x minus 5. And my answer would be 0. X equals 0 is the one solution to this. Now, does that make sense? Well, let's try and see. If I put 0 in here, I'd have 0 minus 5 squared. That's 25. When I put 0 in here, 0 minus 5, -5 times 10 minus 50 plus 25. Yeah, it's 0. So there's one solution to that. Okay. That's a quadratic equation solved best by U substitution. Now, if you went the long way, what you would have done is this. You would have said, okay, let me square that binomial, x squared minus 10x plus 25. Let me distribute plus 10x minus 50 plus 25 equals 0. Sorry, I'm running out of room there. I combine like terms. Look what happens here. Those guys are getting knocked out right there. The negative 10x and the positive 10x. And then I've got x squared. I have x squared minus 25 equals 0. Now, oh my gosh, this is crazy. So x squared, this tells me x squared is 25. See, this tells me I would have two solutions. Now I'm doubting my original answer of having exactly one solution here. Let me see why that didn't work. Because when I square root, I get u plus 5, and I get u equals minus 5. Let's go back and take a look at this. Because it looks like that there are two solutions, that -5 would work here. That if I put a -5 in here, that still is 25. If I put a -5 here, that's a positive 50. That doesn't look like the negative works there. Plus 10x minus 50 plus 25 x squared plus no, it does work. I did this math wrong. See, I told you sometimes I will make a mistake here. When I did this, the 10x and negative 10x do cancel out. I have 25 plus 25, but then minus 50. So the answer is x equals 0. There's only one solution to it. Okay, this was actually x squared. X squared is equal to 0 because the x is canceled out and the constants also canceled out. All right, let's see what we got. All right, there's another statistics one. And they're giving us two data sets, data set A, data set B. And it says that the dot plots shown above, each represent a data set. Which of the following statements best compares the means and the standard deviations of the two data sets? Well, when I take a survey of these answers, they're asking me about the means, whether the means are equal. Okay, and then here the means are different in those two answers. So let's deal with means first. When I have a data set that's perfectly symmetrical, this right here is perfect symmetry, data set A, and my mean has to be right in the middle at 20 if it's perfectly symmetrical. This one, data set B, is also perfectly symmetrical. It's what we call a uniform distribution because it's flat all the way across. But still, it is symmetrical around that stack right there. And so my mean would also be 20 here. So the means are equal. They're not, one of them is not greater than the other. So I'm going to reject C and D. Now they're asking me to compare standard deviations. And I will tell you, even students who have taken statistics, if you ask them like a week after the class is over, hey, could you tell me what standard deviation is? They have a hard time expressing what it even is, okay, much less how to find it. You don't need to know how to calculate standard deviation on this test, but you have to know what it is. And here's what it is. Standard deviation is a measure of spread of the data, meaning how far from the center does the data spread out. And you might be tempted to say, well, it looks like they spread out the same amount. And that's kind of true, but it's not. And I'll tell you why. Standard deviation is the average distance of the points away from the center. So you can see that you could get from data set A to data set B by taking a data point here and moving it out here, and taking a data point here and moving it out, and then taking one of these and moving it, meaning I'm spreading the data out a little further away. This one right here has to have a higher standard deviation because on average, the points are further away from the middle. Okay, so because basically you could picture taking set A, kind of squishing it down and flattening it out, meaning you moved some points out away from the center. That means it has to have a higher standard deviation. So my answer is that the means are equal, but the standard deviation of A is less than the standard deviation of set B. So I go with that answer. All right, I hope that was helpful on standard deviation. All right, I'm going to scroll down and see how many more I have. I just have 2 more questions. So let's cover these, and then I'll talk about a pacing strategy, and then we'll pack it in for tonight. This is an exponential equation. It's exponential growth. That's what it is. And if you know anything about exponential equations, you know that the parent function of an exponential is basically a times b to the x. And an exponential equation, what makes it, or one of its characteristics, I should say, is that it has a horizontal asymptote at y equals 0. That if you look at that function, you will have a horizontal asymptote setting on the x-axis. If I said y, I meant x-axis. It's a horizontal asymptote, and then it goes up like that. But it's very obvious from this graph that it has been shifted, vertically shifted up by 1, because the horizontal asymptote is not on the x-axis. It's instead at y equals 1. And there's only one function that has a vertical shift of 1, and it is this thing right here. So that's all I need to use to distinguish these functions from one another. This would have a horizontal asymptote at y equals 0, or x-axis. So would that. This would have a horizontal asymptote at y equals 2. It would be a vertical shift of 2. There you go. And so that's my answer. That's one of those questions that if you understand exponential functions, it doesn't take you hardly any time at all. It's a very fast solved problem. All right, you can see I picked a lot of statistics and probability functions here, and I hope this will help you pick up maybe 1 or 2 questions on the test here, because a lot of students that haven't taken statistics are at a little bit of a disadvantage, I think. Even though in our curriculum we're supposed to have covered all of these concepts, you just don't learn them as well until you get into a statistics course. And I highly recommend AP Statistics. I always tell my students that if I were governor, I think my first executive order would be to require every graduating senior to take a statistics class as a mandatory graduation requirement. It's that important that we understand statistics. Anyways, this says the class, or the table, shows the distribution of class sizes for the 109 classes of a high school. So these are the sizes, and this is the frequency, meaning how many classes have that size. And I know that there's 109. I don't need to add them up because they told me it's of 109 classes. It says, what's the median class size? Now, what will happen to a lot of students is they will say median, that's the middle. Yep, that looks like the middle to me. It must be 23. Is this multiple choice? No, this is open response, right? You'd say that's the middle. Well, but that's not quite the middle, right? What you have to do to find where the median is find the middle class out of the 109 classes. So if you were to take all 109 classes and list them from the smallest, which would be obviously 21, and you listed all 109 and then got to the highest class number, the largest class size, 109, the middle would be right in the middle of 109, 109 divided by 2. Actually, what we do to find the number of the class that's at the median is we actually add 1 and divide by 2. If you don't remember that, it's not a big deal for the SAT. But if you do take the number of things that you have that would be sorted from low to high, add 1 and cut it in half, well, that's 110. That would be 55. That means class number 55, ranked lowest to highest, would be the median. Well, then what I'm going to do is I'm going to count from the bottom and see where the 55th class is. Here I've got 10, and then I've got the next 13. So now I've got 23. 23 plus 30 is 53. So my 53rd class, ranked lowest to highest, has a class size of 23. Well, guess which class size class number 55 has? It's going to be in this group. My median is 24. That's my median. That's how you find median. You can also do that with a histogram, right? If you have a histogram, you can look at the heights of the bars of your histogram and see what the frequency is in each one of those groups and add them from the left until you find the stack that contains the middle number. And remember, when I say the middle number, I'm talking about the middle number of the things that are lined up from low to high. So if I got 109 things right in the middle at about 55, that's the class size counted from the bottom. That would be the exact physical middle. All right, so that is all the problems that I was going to work through today. So I thought then I would just kind of discuss quickly about the 2-pass system. And it looks like Nick is probably still here. So I've already gone over this with him, but if you're watching on the replay, hopefully this will be helpful to you. But whether it's the SAT or the ACT, what you want to do to manage your stress level and also make sure that you don't leave any easy questions unanswered because you ran out of time is you need to put your eyeballs on every single question. You need to make sure that you do that. And the best way to do that is to go into the test knowing that you're going to make 2 passes through the test. Your first pass, you are going to answer those questions that are easiest for you to answer. And by that, I mean that when you read the question, you pretty quickly identify how to solve it, and you're able to solve it within 30 seconds. If you don't understand how to work the question when you first read it, or it looks like it's a long question, maybe a long word problem, and it's going to take you a while, or your reaction is, oh my gosh, these are the kinds of questions that I'm always bad at, then go ahead and skip it on your first pass. That way, what you're going to do is you're going to get to look at every question from beginning to end and answer the ones that are easiest for you. And then there's no chance that you're going to get stuck on one problem, one hard problem, and then you start to tense up because you realize, oh my gosh, I might be running out of time. That's not going to happen to you because you're going to answer the easiest one on the first pass. And if you do that and stick to the 30-second maximum, you will have at least half of your time left when you go back and make your second pass. And you're going to have already looked at all of the problems. So you're going to have an idea of what would be the next easiest problems to do. And you do the next easiest ones. And if there are some multiple choice questions that you tried to solve them, or you looked at and you realized I just don't see a pathway to getting it done, and you didn't get to those, that's okay, because you're going to guess, right? Those are questions that you would put a bubble in a guess on those. And also, if there are a number of questions for which you don't have an answer, you didn't have time to get to them, and you skipped over them, be sure that you pick an answer for the day, right? A, B, C, D. It doesn't matter which one, but pick one and make all of your guesses the same answer choice. Don't just randomly bubble in answers for guesses. Be deliberate and pick the same answer. That is the statistically valid way to maximize your chance of getting the most guesses correct. All right, so I won't go into why that's true. It just is. It's just it is something that is true when it comes to guessing. And I think that is about all that I have for you. Just make sure to get a good night's sleep before. Don't stay up till 1 in the morning. Don't stay up doing cramming a practice test or anything. Get a good night's sleep. Try to have a normal breakfast for you. Don't go on an empty stomach. And make sure you get your calculator charged. If you have a TI-84 that has batteries, requires batteries, I would swap out the batteries with fresh batteries, okay? And if it's a charged one, be sure to charge it the night before when you go into the test. All right, I still got 2 people here live. Anybody have any questions? I haven't seen any questions pop up, but I sure hope that it was helpful. If you found it helpful, if you would hit the like button, and if you're watching it on a replay, hit the like button on YouTube. That would help me out, and feel free to subscribe to my channel, because I will have more content coming out on ACT, SAT, and AP classes throughout the year. All right. Well, thank you for joining, those of you that came in live, and I hopefully will see you sometime soon, either here on a live stream or working with you one-on-one. All right, everybody. Good night. Good luck on the test on Saturday, and I'll talk to you soon. Bye.